Hello everyone and welcome back to my channel. In today's video, we are going to talk about the two-pointer approach. The two-pointer approach can be used in arrays or can be used in strings. So why do you use the two-pointer approach and why is it very important? In two-pointer approach, you can take your time complexity from O(n) square to O(n), which means you significantly reducing your time complexity from n square to n. N square occurs because we are using a nested for loop. Whenever you're using a nested loop, while for loop, whatever you use nested, it comes to OS square or sometimes can actually escalate to n cube. So in or go for whatever it is. But in this case, if you want to reduce it from n square to n, you actually use two-pointer approach. When do you use n square? For example, let's take this array and you want to, for example, let's have this one single number and you want to go and check with this number, you want to check this one, you want to check with this one, and you want to check with this one. You can't do this using a single loop because if you're going to use a single loop, it's going to only go through this entire array 1 2 3 4. That is it. It will not compare you with all other elements. So what you use is, if you want to compare this element with these two elements, for example, then you have to use another for loop. So the first for loop will go through this element and the second for loop will help you to go through the other next elements. So you need a total of 2 loops for you to go through this. But when you're using a two-pointer approach, you just use just two variables and the one single loop to iterate through the entire array. It saves you a lot of time. Okay, so let's get started with the approach. So this is the first approach, two pointers from opposite ends. So mostly you use it in a sorted array. Today we have a problem statement here. Now this problem statement is a two sum in a sorted array. Okay, so let me explain it in a simple way. You will be given a sorted array and you will be given a target. Now you have to go through each element in the array and you have to take which element adds up to give you the target element. As I already told you, when you take this array 1, 2, 3, 4, 6, you need to find out two numbers that add up to give you the target element. So what two numbers can add up to give you the target element? So when you want to check like this, the first thing that is you choose a number, for example 1 in this case, and you have to go through all the numbers 2, 3, 4, 8, 6, and you need to check whether anything adds 1 plus, let it be 2, let it be 3, let it be 4, let it be 6, any number that is adding up to give you this element, the target element, which is 6 in this case. So you have to check through everything. So in this case, mostly we'll be using two for loops, but here we're going to use only 2 pointers and we're going to find it. So the base idea is to keep 2 pointers in the opposite ends. That means one at the starting and the other at the end. So you keep one pointer over here and other pointer over here. So this one is left pointer and this one is the right pointer. Okay, so this one is going to be at the starting variable, is going to be assigned to the starting position of this array, and here the variable is going to be assigned to the end of the array. Now what we do is we give a stopping condition so that it doesn't make any issues. So the stopping condition is basically your left index, that means the position of your left should always be lesser than the right. When left goes crossing the right, That means you have traversed through the entire array and the condition is over. That means you don't want to loop through infinite over the same possibilities again and again. So this is your stopping condition. Okay, when left surpasses the right, that means when left comes after the right, that means your condition is stopped. Okay, let's see how it moves and what it does. So first we are going to calculate the sum. We're going to calculate if the left the element at the left and the element at the right position will give you the target element. In this case, 6 plus 1 gives me 7. That means right now I didn't get my target element. In this case, you can see 7 is the target is very greater than this target is the target is actually lesser than my sum that I got here. This is the S value and this is the target value. So this else condition will work now. In else condition, we have to move right back. So in this case, right will be moved here and left will stay still there. That means with this number, we will take this number. 1 and 4, when we add 1 and 4, we are actually getting 5. This 5 is lesser than our target element. This is our sum. This line is getting executed now. Sum is equal to array of left plus array of right. So array of left is still here and the right position is here. So this goes 5 is less than the 6. That means we will move left ahead. So now left goes here and right stays in the same position. Now this element and this element will be getting checked 2 and 4, 2 and 4. When we do 2 and 4 in this case, we are actually getting the target element. That means 6 is actually equal to 6. That means this if condition will be executed. We will print the position where we got it. We will print the position 0, 1, 2, 3, and 4. The position is 1 and 3. Okay, now let me actually give you a quick approach of how we are doing this. In this case, we are actually using in this case um, you can see that what is happening here is that two pointers are moving towards each other. Let's say a left and right. Now these both of them are moving towards each other. When you want to move the pointer, make sure you move the left pointer forward and right pointer backward. So whenever you're giving a condition, you have to move your left forward putting a plus plus, and whenever you're giving a condition you have to do right minus minus. So these two will be only executed when your condition is not satisfied. That means the number that lays on the left and the number that lays on the right doesn't match each other. So that's why you have to keep moving it. Okay, now the reason we moved the left pointer when we didn't have the target and um the target is greater, because when we are standing in a smaller number and we didn't get the expected result, we move to the next number to find a larger number because our target is larger than the sum we actually got. Now, why do we minus the right? Because the right is at the largest end. That means the numbers towards the right pointer is actually pretty large. So in this case, we want to find a target that is actually smaller than the sum. So when you want a target that is smaller than the sum, you want to make sure you approach the smaller numbers. So in this case, to reduce it, we are moving the right pointer over here, where we have lesser number. Okay. Now we're going to talk about the sliding window approach. The sliding window approach is mostly used for subarray problems or substring problems. Now I'll explain you what is a subarray. In this case, we have an array right over here. Right, let's create a new one. So let's have it array 1, 2, 3, 4, and 5 in this case. In this case, to talk about a contiguous subarray means that these two is a subarray. They should be continuous. For example, let's say this 1 and 4, they cannot be a subarray. This is not a subarray. Contiguous means continuous sequence of numbers. That means 1 and 3 can be a subarray. That means 1, 2, 3, all of these can be a subarray, or 1, 2, 3, 4 can be a subarray. All the elements together can be a subarray. A single element can also be a subarray. For example, this 1 can be a subarray, 2 can be a subarray, 3 can be a subarray, 4 can be a subarray, 5 can be a subarray, contiguous subarray. You can also have 3, 4, 5, 2, 3, 4, 5, whatever it is, but it must be contiguous and it should not be like this 1 and 4 or 5. This is not, because 2 and 3 are missing over here. That is not contiguous. So in this case, we only consider continuous elements. Okay, and now the sliding window technique will use two pointers. One will be at the start, another one will be at the end. Now this pointer, they are in Now this pointer will be in the same direction efficiently, okay? They will be in the same direction and they will not be in different directions, okay? Now let's go through the maximum sum of subarray of size k. Size k is the size of your subarray. For example, let's say that k is 3, that means you can have continuous 3 elements in your answer. That means 215 can be a subarray of size 3, or 151 can be a subarray of size 3. That depends on whatever size you're doing. You can also go with 513. You can also go with 132. Now these are the possible subarrays of size you can have. Another thing is that you need to take which subarray has the highest sum. Now this subarray 215 gives me 8. This one over here gives me a sum of 7. 1, 5 and 1 add together 7. 5, 1, 3 add together it's actually 9. 1, 3, 2 add together it is actually 6. So you can see here which one will actually give me the, the highest value. Okay, now we're going to have two pointers here. In this case, it's going to be the start of your window and the end of your window. That means, let me explain. 215 will be the first window, and this first window, we will add up all of these elements inside the first window, and we'll store it in a variable called maxSum. Okay? Later, we go inside the other elements, because we just don't need to add the first 3 elements, we need to add all other elements also in this case. So we will have a pointer that is starting from this element. Now next, the number will cover 151, leaving the first element. It will exclude the first one, and it will include the next number inside the window. Now this process will continue. Now in the next window, the first number will be excluded, and now the next number towards the end of the window will be added. Okay, this is going to be the third window, 513. Now in the next window, this element will be excluded and this element will be included. So 132 will be included. Now let's talk about what we're actually doing here. Okay, so basically what we're doing here is we're taking the sum of the window. So first what I'm doing here is so we got a sum over here. So this is the sum we got. Okay, so what I'm doing here is basically what happening here is you want to understand. Let's take an array 215. In this case, this is the sum and we found the sum. Okay, so 215, the sum of this is going to be 2 plus 1, it's going to be 8. Now for the second window, we will exclude this and we will include this one over here. So 151 is our new window. In 151, what is the sum? This is 7. How are you calculating it? How are you calculating it? In this case, you know that the previous window sum is 8. And you already know that the next window is going to include another number, which means we will be excluding the first number over here. So it will be 8 minus 2, that will be 6. Now the 6 will be including the new window size is going to be excluding this number over here. So you can see 1 and 5 is already pre-calculated over here, which is 6. We just include the new value over here, which is 1. So 6 plus 1 is 7, which is our new value you can see over here. So this is the code that you need to use. Array of n minus array of n minus k. The n value is nothing but the range that is starting from k. In this case, the first window 215 is pre-calculated before you even start the before you even start creating a window. So you calculate the window sum and you assign it to be also the max sum for initially. Okay. Now in the for loop while you enter, you actually start your window sum place equal to. So in this case, you will be including the array of n, which is 0, 1, 2. It will going to start from the size of your subarray, which is 3. Okay, 3. Now in this case, um, this is the element. So you start from 3. So this element, the third element, will be included in your array. So you do place equal to with your window sum. Array n minus k, this one will be subtracted, which is this first element. So the formula n minus k, n minus k, what it actually does is n value over here for the first iteration, it's going to be 3 minus the k value, the size of your subarray is going to be 3. So it's going to choose the first element, so 0. So 0th element is 2, which over here will be neglected. I hope this is quite understandable. Basically, you just start with a first value and then you just expand your window. That means if this window, this is the first window you check, and then you exclude a number and then you include another number. Okay, and then you exclude this first number and then you include the next one. So the size is already given. So we'll see more problems on this so you can have a clear understanding. Now let's talk about the types of your sliding window. Fixed size window. In this case, your size will be given the subarray size, like already given here. For example, in this case, 3 or 4 or 5. They already mention you what is the size of your window is going to be. That means you have to find the answer within that window. For example, 3, your answer will lay between these 3. Variable size window is equal string and add based on your it's not a fixed size. For example, let's take an array of elements of 5 elements and they tell you to find the maximum subarray of maximum sum, something like that. So in this case, let's say 1, 2, 3, 4, and 5. Okay. Now in this case, we check with the first window, the first element 1. Is this a greater sum? Yes, so in the max sum, I put 1 over here. This is my max sum, okay? I'm checking it over here. Now in the second subarray, I will expand my window and 1 and 2. I will take 1 and 2. Is 1 and 2 greater? 1 and 2 added together give me 3. So now this is the maximum window. Now maximum subarray. Now when I go to the next element 1, 2, and 3, in this case my maximum subarray is going to be 1, 2, and 3, which is 6. Now this 3 will be updated to 6. Now when I expand my next window, in this case you can notice the size of my window is not a fixed size. Here at first my size was 1, the second my size was 2, next my size was 3, and next my size is becoming 4. This is what is a variable size window. In this case, all the fill window, that means 1, 2, 3, 4, 5 will give me the maximum sum 9, 10, 11, 12, 13, 14, 15. 15 is the answer. 15, this is the maximum sub array sum and it will be given by the entire window. Let's get another example. Okay, this is another example over here. In this case, you can notice the subarray. It will keep expanding 1. This is ignored. 0. It still remains 1. And then this entire thing is ignored. And then 1 and 1 will give me 2. And again, expand it. Let's have it 0 in this case. So expanding it will give me 4. In this case, the largest subarray is this. This will be calculated, but it won't be included here. 1, 0, 1, 2, and 0. This also gives me 4. You can also take this as the subarray and this as the subarray. Let me give a good example. Now this is the first one. This will be taken as the maximum sum, and then this one will move next over here, which will give me 1. Now this will be taken as the maximum. When I cover over here, this one actually gives me 2 and 3 and minus 1. This actually gives me 4 over here. Okay. Next one, this entire subarray will be taken. Now this will be giving me 5 over here. Now the next subarray we take from 2, 3, 1. This gives me 6. The next subarray we take 3 and 1, which 3 and 1, which gives me 4. So when I take 3 with the maximum over here, so this entire subarray will be taken. And if you cannot update the result by just adding or removing one element, you cannot use the sliding window approach. Remember that.